In this application of quadratics word problem, we are told that Maria produces and sells shell necklaces. She sells each necklace for $3 and she averages 40 sales per week. She has been told that she could charge more, but has found that for each 50-cent increase in price, she would lose 2 sales each week. We are asked what selling price should she set to maximize her revenue. So we see this word maximize, which tells me this is a MaxMin problem. If you have the words maximize, minimize, the greatest, the least, this helps you identify if it is a max or minimum problem. So here what we are interested in is the vertex. But before we find the vertex, we need an equation. So we are trying to maximize revenue. So we need an equation that is going to give us the revenue that Maria can make after she changes her price. These revenue questions are quite common, and it is often useful to set up a table to help derive the revenue formula. So I have a table here. I have price, the number of sales, and the revenue. So let's start off with what Maria is already selling. She sells a necklace for $3. So when the price is $3, she makes 40 sales. So her revenue is how much she gets in total, which is $120, 3 times 40. Maria knows that if she increases the price by 50 cents, so her new price would be $3.50, she would lose 2 sales. So that means she's only selling 38 necklaces. So the revenue would be 350 times 38, which is 133. So her revenue, we can see, has increased. And if she increased the price by 50 cents more, she would be charging $4 a necklace, but now she would only be selling 36, which gives her a revenue of 144. Now from this pattern that we're seeing, let's create a formula. So the price starts off at $3, and we increase by 50 cents X number of times. We don't know how many times we're increasing by 50 cents. Our number of sales, we start at $40 and we lose 2 sales X number of times, depending on how many price increases that Maria makes. And then to find revenue, we multiply the price times the number of sales. And we find that the revenue is 3 plus 0.5x times 40 minus 2x, where x represents the number of price changes. It is important that you have a let statement so you know what x represents. So x does not represent the price, it does not represent the revenue, it represents how many times we change the price, which affects not only the price but the number of sales. So we will take the revenue formula, which we found above, and I just rewrote it on one line, and we want to find the vertex. There's 2 ways of doing this. The most common way that students use is by completing the square. So to complete the square, I'm going to expand these 2 binomials, and I get the revenue is equal to 120 plus 20x minus 6x minus x squared. So next I'm going to collect like terms and write this in the form ax squared plus bx plus c. So I get the revenue is equal to negative x squared plus 14x plus 120. So now to complete the square, I'm going to factor out negative 1 from the first 2 terms. And I get x squared minus 14x and bracket plus 120. Next, I'm going to take that negative 14 and I'm going to divide it by 2 and then square it. So I get negative 7 squared, which is 49. So now I'm going to add and subtract that 49 inside the brackets, like this, and I wrote it in red. And then I'm going to take the negative 49 and multiply it by negative 1, which is my a value, which I factored out at the beginning, and move it to the outside of the brackets. and I get r equals negative x squared minus 14x plus 49, which is a simple trinomial, plus 120 plus 49, because negative 49 times negative 1 is positive 49. So now I'm going to factor this perfect square, and I get the revenue equals negative x minus 7 squared plus 169, because negative 7 times negative 7 gives me positive 49, negative 7 minus 7 gives me negative 14, and 120 plus 49 gives me 169. So now I have completed the square, so I can identify the vertex, which is 7, 169. So here's a quick sketch. I know my parabola opens down because the a value is negative. So this value is a maximum, this vertex, which is good because we were asked to maximize the revenue. So now let's read back to the question and interpret our answer. So we are asked, what selling price should she set to maximize her revenue? So here with the vertex, we know that x is equal to 7, the x-coordinate of the vertex. And if you look back at our let statement from above, we know that x represents the number of price changes. So the price is not 7, but we can use this value of x to find the price. And if asked, you could also use this value of x to find the number of sales that she makes when she maximizes her revenue. And we could also be asked what the maximum revenue is. And we can do that by substituting in the value of x equals 7 into the price equation, x equals 7 into the number of sales equation, or if we want to find the revenue, we can substitute it into the revenue equation. This question only asks what the selling price is to maximize the revenue, so we are just going to substitute it into the price equation here. So we know that price is 3 plus 0.5 times x, so the price is 3 plus 0.5 times 7, which is 3 plus 3.5, which is 6.5. So to maximize her revenue, Maria needs to charge $6.50. I just want to take a minute to explain another way you could have solved this problem. In this unit, we have looked at two ways to find the vertex. The one way was completing the square, which is the most common way that students will approach this problem. But the first way we looked at in this unit is actually solving this equation. So to solve, we set the revenue equal to 0. And what we notice is that this equation is already in factored form. So we can simply solve by taking each factor and setting it equal to 0. So 3 plus 0.5x is equal to 0. So 0.5x is equal to negative 3. Divide both sides by 0.5, so you get x is equal to negative 6. And the other factor, 40 minus 2x, is equal to 0. So 40 is equal to 2x. Divide by 2, and you get x is equal to 20. So what we just did is solve for the x-intercepts of that revenue equation, so negative 6 and positive 20. But again, we are trying to maximize this problem, so we want the vertex, or at least the x value of the vertex. Well, the x-coordinate of the vertex lies on the axis of symmetry. So to find the axis of symmetry, we average the two x-intercepts. So negative 6 plus 20 divided by 2, which is equal to 14 divided by 2, which is 7. So the axis of symmetry is x equals 7. And if you remember from our above, we found the vertex to be 7, 169, and we were only interested in the x-coordinate of our vertex. So then we would continue and substitute in our x value of 7 into the price. So again, the price is 3 plus 0.5 times 7, which gives us the same answer as $6.50. So again, just a reminder, there are two ways of finding the vertex. This way is actually a little bit faster because the revenue formula was already in factored form when you made it equal to 0.